Hello everyone. So welcome back. Let us start from where we left in the last class. So when we finished our last class, what we were discussing about was a interesting effect called rebound effect, where we were looking into that energy efficiency can lead to a very interesting human behavior, which was basically consuming more because you are suddenly equipped with more money or more resources in your pocket, and that effect is known as rebound effect. And it is, as I mentioned, this effect is not something new phenomena which people have come to know about. This has been known in history from the days of steam engine itself, but we trying to move towards a net zero issue, and where efficiency is becoming the key, one of the key drivers of whole of this journey. This rebound effect is impacting this overall this journey of net zero very interestingly in a negative way, but it's a human behavior thing, and so we have to account for it while we make all our transition plans. So as we all understand that net zero requires absolute emission reduction, not intensity improvement. Like we have talked about this a lot, so I will not repeat that point anymore. And efficiency alone delivers relative gains, right? So it is efficiency which is the key in the whole game, and in terms of reducing the energy consumption is what we are aspiring for. Now, if we ignore rebound effect, then what we will do is that we will just keep on continuing making our plans based on efficiency improvement plans, which will be technical, which will be economical, or whatever we are trying to do, but we will continue to make it using a plan which will be efficiency driven. And if we are not accounting for rebound effect, we will be ignoring that. You remember I talked to you in terms of equation which was R is equal to 1 minus So it is actual energy reduction versus the expected energy reduction. So actual emission reduction can be much lesser compared to the estimated emission reduction and energy reduction overall. So this can lead to a phenomena where our gains could be lower than what we expect from the efficiency technology plan. And this is specifically dangerous in a fast growing economics, because fast growing economies will have a lot of people, lot of population which would have been deprived of some of the basic needs in their day to day life on a continuous basis. And since they would have been deprived of some of the basic needs, so as soon as they have more money in their pocket, they have the natural tendency of going and trying to match with the so-called perceived good way of life. So this is an interesting phenomena which has to be kind of taken into account. And whenever we are talking about efficiency, we have to have this structural constraints. We have to have a broader look at the overall picture in a better way. So we will look into some of the numbers in couple of slides, but one more phenomena I want to talk to you before I move to some of the numbers is that when we talk about issue like demand side management also is kind of taking into account some of the behavior aspect, and we are trying to tinker, we are trying to nudge people to use energy at a specific time of the day or a specific period of the month. We are trying to do that because we are trying to avoid the peak loads, and we are shift the peak from the load from peak to valley kind of a phenomena, but it does not affect the overall consumption. Basically it affects that when are people consuming it, it does not constrain industrial output growth. So overall, like DSM would lead to a phenomena where we can, if we can have the right DSM phenomena, we cannot expect people not to have that rebound effect, because rebound effect is kind of a generic effect which affect the efficiency. It does not affect the demand side management so much. So demand side management side also will not be able to handle the rebound effect so well, right? Let us look at some example using understanding this rebound effect in terms of numbers. Like suppose a household initially consumes 100 units of energy using old appliances. The new efficient appliance is expected to reduce consumption to 60 units, and we have talked about this earlier, but I just wanted to show you in terms of numbers. So, but what we observe is that actual consumption only reduces to 80 units because the appliance is used more frequently now. And as soon as we do that, so expected saving or the energy saving was about of 40 units, but while the actual saving is only of 20 units. So then when you put this in the equation, what you basically get is R is equal to 0.5. So 50% rebound is something what we are seeing through this phenomena. So 50% of the gains are kind of wiped off by because the appliance is used more frequently, and this is a phenomena which this is observed in our day to day life a lot, and this could have a very profound effect on overall energy transition plan for any economy. And let us now connect this thing to our favorite equation so far, which is known as chi-identity. So, if you look at chi-identity, what did chi-identity talks about? Chi-identity, let's integrate that with efficiency, and let's also integrate that with rebound effect. So, we know energy efficiency basically reduces E by GDP term. So, this is so our devices are much more energy efficient for the similar amount of economy, and it is a decarbonization policy which reduces this term. So, we will talk about that separately. Now, rebound effect increases GDP per capita through productivity gain. So, this is the parameter which rebound effect starts impacting, because as soon as rebound effect comes into picture, people have more money in their pocket. So, effectively it is the GDP per person, or the amount of money which people have in their pocket per person, or the perceived money. It may not be the actual money, but it is the dispensable income. This money can be divided into two parts. One is the need based income and one is the dispensable income. Now, what can happen is that as soon as you have your need fulfilled with lesser amount of money, you will have more dispensable income in your pocket. As soon as you have more dispensable income in your pocket, you can spend more. So, effectively what can happen is that in turn, so it may not be in terms of absolute money, but what it can happen is that it will give you more money in your pocket. So, with more money in your pocket, rebound effect basically increases GDP per capita from a dispensability perspective, from a spending perspective, and increases the total GDP also through economic expansion, because then people are able to carry out the same amount of task with lesser amount of money. Therefore, efficiency acts upon chi component, while rebound effect feedbacks works on the upstream component. So, the rebound effect starts impacting this component. So, efficiency was impacting this parameter. So, E by GDP is what is reduced by efficiency, and GDP per person is changed by chi-entity. And so, let us not talk about demand side management. I think we have talked about that enough so far. So, you remember that example where we were talking about chi-entity, and what we looked at that. We looked at it from one eye, that energy intensity and was reduced by 25% and carbon intensity reduced by 20%, but we saw that only CO2 only reduced by 8%. Because of the increase in population and increase in GDP per person. So, that is what we saw earlier. Now, let us put another thing on top of it, which is in terms of rebound effect. As soon as that starts happening, now lower energy cost stimulates industry. So, GDP per person rises further because of that by 10%. So, because of that, GDP per person increases to 308 rupees per person instead of 280 rupees, 2,80,000 per person. It increases further by 10% because we suddenly have the rebound effect coming into picture, where people are able to earn more because of this, all this efficiency improvements. As soon as that happens, so new GDP is now 16.9 trillions instead of 15.4 trillions, and so thus energy use is now 76 picojoule instead of 69 picojoule, and CO2 that therefore is now 6.2 million ton instead of 3.88 million ton. So, now if you compare it to the initial number of 4.2 million ton of CO2, which was there 3 years back or 10 years back, which is the baseline number, this was the baseline number 10 years back. Because of the rebound effect, because of this increase in GDP per person, because of the rebound effect, because you have more money in the pocket of people, so the systems become more efficient, people have more money, and now because of that, overall what happens is that despite efficiency improvement, despite renewable deployment, the emission is above the starting point itself. So, it is instead of 4.2, now it is 4.26 million ton. So, this is a very interesting phenomena, which it has simply wiped off the efficiency improvement, and it has simply wiped off the renewable improvement altogether. So, we need to keep an eye on this rebound effect in a very effective way, and if we are not careful about rebound effect, and if we are not making policies which are more comprehensive policies, which takes into account that how people consumption behavior is changing. I remember I told you about this, how the consumption starts changing when efficiency creeps in, is something which, ignoring that fact, can lead to a situation where suddenly the consumption can actually go beyond what was being done earlier. So, this is one aspect of it. There are more behavioral aspect and some more political aspect also which can impact efficiency. Let us look into this before we move into some other topics further, right. So, barriers for energy efficiency investment is that higher upfront costs deter adoption, while so there are issues with energy efficiencies which kind of are there. energy efficiency devices are still perceived, or in some cases actually are, like star rated ACs versus non-star rated ACs, or maybe 5-star rated AC versus 2-star rated AC. Like, so there is some initial cost barrier which is there, which leads to adoption, because the people may not have that kind of dispensable money upfront to use those kind of devices. Limited access to financing also restrict some small and medium scale projects, because those projects may not have that dispensable money with them to improve their efficiency through technology deployment, because some of these technology deployment aspects need money to be used in the system. And the small businesses or the medium sized business may not have that money to spend on that efficiency projects. So also behavioral resistance, we have talked about that earlier, so I will not go into that again. Information gap is another thing which can lead to efficiency adoption not happening. So people may not actually understand that what is the impact of this efficiency on their day-to-day life. So there is a huge information gap which is there, and that is where the behavioral trading, and this is one of the topic of research which I personally get involved in also, along with technology part also, that people need to be taught in terms of, or people need to be made aware of what is in it for them if they adopt these efficiency plans. And there, on top of it, there is a complex regulatory process. Like I talked to you about one phenomena which is demand side management, and I talked about complexities on that hand with respect to smart meters, about having integrated software system, about working between various agencies, interdynamics or interplay of those agencies, those comes into picture. So overall, this is a complex system that we are working in, and since there are multiple agencies which are involved. So from a regulatory perspective also, if you are trying to bring in this efficiency and you are trying to pass on this benefit to the end consumer of this efficiency, it is not so easy in the current regulatory framework. And also the incentives maybe sometimes could not be compelling enough for people to adopt to it, because the benefit seems to come in a very long term way, and people might be needing to give money upfront, which kind of deters them to do this intervention behavior upfront. There are further interventions around it. Energy consumption is strongly dependent on habits, comfort expectation and social norms. So sometimes people want to change some of the behaviors, but or people understand certain aspects, but very difficult to change the people basic habits. Comfort is a perception. So what temperature you feel comfortable at your home? Are you comfortable at 22 degrees AC, or are you comfortable at 26 degrees AC? That is a very perceived way of looking at your comfort. That entirely depends upon your thought process, that what makes you feel comfortable, because there is no scientific basis of comfort. There are scientific numbers around it, but then people can say that my body behaves differently than others, right? So that is a very perceived kind of a thing. Social norms also sometimes leads to such a behavior where people end up using some devices in an ineffective way, because that is what the social norm is, and it is very difficult to go against the social norms for most of the people. Also, as I already talked about, that efficiency improvement leads also can create a psychological license to consume more. I think I've already talked about this rebound effect, and also I've also talked about that overall the reduction could be modest in terms of overall efficiency improvement phenomena, because what is seen is that as soon as people have more money in their pocket, people can start behaving very differently, right? Not only at a personal level, not only at an individual level, these energy efficiency things can also start impacting systems at a bigger level also. Like for example, industries, whenever they are investing in any money, like so industries usually works on ROIs. Individuals, we individuals, we don't work on a phenomena called return on investment, or we don't do that kind of a maths in terms of when we are buying any devices. For example, working in industry, if industry is working towards deploying any new devices with for energy efficiency aspect, they would immediately convert that into some kind of an ROI phenomena, and so there might be some saving coming around it. And usually the benchmark, it can vary from industry to industry, but usually industries in the current very fast changing economic thought process, they expect a ROI between 1 to 3 years. And if they are expecting that ROI to come into 1 to 3 years, sometime if the maths is not looking very lucrative upfront, or they are not able to see that benefit directly coming to them, it can lead to a slowdown of adoption of some new technology. Also, Sometimes these incentives are giving through some tax structures or some depreciation rules, or there are depreciation rules around it because they might have invested into some equipments earlier, and those assets are still depreciating. So and they were not able to depreciate it before they start, because they might be using some kind of depreciation norm. They might be doing some linear depreciation. So now suddenly if they want to write off an equipment, either they take hits on their books, or if they want to write it off equipment at this point, it will not be so easy given our depreciation rules phenomena. I'm not going to economics of that. There are economics challenges around it, or tax structure challenges around it. There is mismatch between industrial planning cycle and efficiency programs. There could be mismatch around it because industry may not be willing to take that hit in terms of change of equipment from equipment A to equipment B, because they may have production pressures and stuff like that. They could be split incentive across departments, which can dilute responsibility, because within the industry also there are multiple cost centers or multiple center of excellences, or multiple departments which are working in a handshake mode. So if they are working in a handshake mode, so then it's very much a possibility that the efficiency program may be benefiting one department while it doesn't impact the other department, and the other department might need to do some more work to absorb whatever efficiency is being brought into picture by the previous department, and that the other department may not be willing to put in that effort. So that's where the top management needs to come into picture. But so that's where these kind of inter-department play also comes into picture. Non-energy benefit like productivity, reliability, very difficult to quantify those things usually. So if you are not really spending time deeper into these things, so some big corporates can do that because they may have the bandwidth to do that calculation. They may have people who can be deployed to look into this kind of equations. Some of the smaller organizations, MSMEs for example, or some small enterprises which might be working on these lines, may not have the right skill set or may not have the right bandwidth to look into the overall non-direct benefits, like non-financial benefits, which are not very obvious on the face of it. So this can lead to a phenomena where they may not see the whole benefit the way it should be. Another thing which kind of sits in the background of all of it is price volatility, because money is also volatile. Rupee is depreciating at the international level, or even talking internationally, there is a lot of volatility around it, given the geopolitical situation and everything. So everywhere, so it's kind of a risk that you are moving into a more efficiency based picture. Are you ready to take that bet is something which industry need to take a call. There might be regulatory barriers which could be around this thing. So sometimes business models also discourage promotion of reduced energy sales for some specific corporates. That could be an issue. Opt-out provision reduce energy industrial participation in efficiency programs. So there could be issues where people may have to opt out of certain processes that they have been doing, and they have to move to some different processes applying this efficiency program. So that is where the issues can come in. So an efficiency overall is always not treated as resource in integrated planning, because that is kind of given in a system that people are expected to work in more and more efficient way. But what we are talking about is a disruptive efficiency here, and that disruptive efficiency is not always worked in a integrated planning model. So overall, from an industrial perspective, so though it may look a very lucrative phenomena, as we talked about earlier, that it may give more money in your pocket, since that money is not coming upfront, since that money is coming in a slow trenches, and with the kind of volatility of that a business environment works in, sometimes businesses are not ready to take that bet for having a brighter future for a weaker present, where they may need to shelve off some money to deploy some of these energy efficient devices. There could be political outcomes which might be leading to this slow deployment of it, because energy demand is shaped by tariffs, subsidies, infrastructure and institutional designs, and since demand is being driven by this. For example, let me give an example. I talked to you about agri sector, and when I am talking to you about agri sector, we all understand it in India, a lot of agriculture sector is working on subsidies. And if it is working on subsidy, now the consumption of the sector will actually depend upon that what kind of subsidy are you getting. So consumption of the sector is not directly depending upon the kind of energy efficient devices that you need to work upon, or you cannot expect people to behave in a certain way when they know that even if they use those devices at X time of the day or Y time of the day, they will not be paying money from their pocket. If they will not be paying money from their pocket, why should they put in that extra effort to not use the devices during the peak hours and using it during the valley hours? Like, even if you give them some financial incentive of using the devices at this particular time, they may not use it because they are more comfortable. They have the behavioral aspect of using the devices in a specific time of the day. They don't have any incentive of using it at other part of the day, because in both cases they are not paying bills. If they are not paying bills in both the cases, if they are getting subsidy, if their tariffs are designed in a certain way, they may not adhere to these kind of changes. So, I think I have talked about other aspects a bit earlier, so I will not repeat them. Therefore, it reflects government choices rather than a neutral market outcome. So, what the point I am trying to build up here is that energy efficiency, though it is a very known phenomena, it is a phenomena which can lead to high amount of changes overall with respect to the energy reduction for a country, company, or for an individual overall. There are multiple challenges around it. One challenge which I have talked to you about is the economic challenges, where people have the tendency, a natural tendency of using more when they have more money in their pocket. Then on top of it, we have a regulatory phenomena which is not as straightforward, because there are multiple stakeholders which are part of that picture. And since there are multiple stakeholders which are part of that picture, it can lead to a situation where the situation becomes so complex that either all the agencies within the government system or within the organization systems works in cohesion, everybody is talking the same language, everybody is working in an integrated manner. Otherwise, to deploy such a efficiency norms in a well set structure may be very difficult. And on top of it, there are political compulsions of giving subsidies. On top of it, there are social issues of looking to use devices or using the equipments in a certain way, because society around you is using it a certain way. Then there are behavioral issues around it. So, I am talking about economic issues, I am talking about political issues, I am talking about social issues, there are behavioral issues. So, overall there are issues around it which could lead to very complex situation, and the efficiency may not be as effectively deployed as we want it to be deployed. There are information and capacity barriers also, which I already talked about. So, I will just let these slides to come to you, and we can discuss it offline, but I have already talked about it. And these structural barriers can lead to behavioral mechanism also. So, while economic and regulatory barriers explain why efficiency investment stall, behavior mechanism explain how individual organizations actually make decisions. So, these mechanisms can shape up pricing choices, technology adoption, energy usage pattern, participation in DSM program. So, on one hand, there are regulatory challenges, on one hand there are economic behaviors which are expected. On top of it, what these things can shape is basically appliances choices, they can shape technology adoption, they can change a lot of things in the society which you may not be looking from a very direct eyes perspective. So, it is not always maths driven, it is not always numbers driven, it is not always driven in a way that people can work on logics. There are much more complex situations where people work on. There is another situation where status quo bias, right? Why should there is a whole inertia in the system which is sitting. So, change is perceived as a loss. So even if you have for example, you have a fan in your house which is running at 80 watt, and you now have a new fan which is now running at say 28 watt, and it can give the same amount of air. That is what you are looking the fan to do. And you know that ROI of this fan, so though we do not calculate ROI as at home, but let me talk in terms of industry also, or maybe a government office also. So, you have a fan which can give you 28 watt, and you know that ROI of that, depending upon the users, can be within a year or so. But who will take that call of writing of the devices of, suppose you have 100 fans sitting at 80 watts, who will take that call of writing of those fans at of 80 watts older fans? So, though you have an ROI of 1 year, though those new fans might be coming with a life guarantee of 3 to 5 years, and it makes all the economic sense, but a perception of throwing away devices is so difficult to take a call on. So, that is why there might be a very slow diffusion of efficient devices and retrofits. What I am not going into is that what will happen to these 80 watt devices which are kind of discarded. will they go into landfills or will they be recycled in the whole system? I'm not going to that discussion right now. So that's another difficult question to answer because then it will lead to newer consumptions. But specifically sticking to energy efficiency thing, these kind of behaviors can lead to a situation where energy efficiency can be slowed down a lot by this effect also. Another aspect which I've kind of touched upon earlier is about subsidies, because subsidies are given in any economy these days as a political tool, and sometimes these subsidies are a kind of support the welfare of the weaker part of the society. They protect farmers, they protect industries from price volatility, they create politically powerful beneficiary group they create. But since these benefits are concentrated, costs are diffused, the subsidy regimes always persist, they always persist. Now, as I told you already that because of this subsidy coming in, the subsidies works as rebound multipliers, because as soon as you have subsidies coming in, people know that they have this energy efficiency coming into picture, because of which their cost will reduce. Suppose, okay, let me give you an example. You have a government who is giving 200 units free per month. Now, you had a electricity bill of, so you are currently using 300 units at your house. Now, from 300 units, you put energy efficient devices and you start using 200 units. Also, maybe that's not a very good example. Let me rephrase these numbers. Suppose you are getting 200 units as free right now, and you have been using 200 units only, and you were not paying any bill. Now, somehow you put in the energy efficiency devices, and you are suddenly need to use only 100 units. I'm taking an exaggerated case. So suppose that 150 units now you need to use, because that's what after the energy efficiency coming into picture, that's the amount of unit that you need to now consume. Now, you know that you are getting 200 units free. So, you will have a natural tendency, because of the subsidy coming in, is to use additional 50 units, because those units are coming to you for free. So, subsidy in a way also multiplies and also adds into the rebound effect. So, the people could have easily used 150 units, and they had a very good ROI of this from a devices perspective also. This issue of having subsidy with you prompts you to use the amount of energy which you get for free, or the amount of subsidy that you are getting, you want to fully utilize that subsidy. Not utilizing full subsidy also is perceived as loss, which is a very, very strange phenomena, that you are getting subsidy, and actually subsidy is kind of an upper limit, but people have that human tendency of that if I am giving discount of 20% or something, let me try to avail and optimize that 20% discount. Though I need to use that specific thing or not, do I need to use that much of energy in terms of the 200 units or not, is a separate issue altogether. As soon as you know that you can get 200 units for free, you will work towards using 200 units. So, that's a very strange human behavior, but that's how we do. So, I already talked about agriculture case, so I will not kind of go into that again, but like what can happen is, as I talked about in terms of industries, that it can lead to a situation. Similarly, in agriculture case, I have already talked about that it can increase pumping hours, it can increase integrated area. There are interplay of these issues which kind of creeps in a lot. India's PAT scheme also, which talks about specific consumption, the plant level energy efficiency improvement. But however, there is another aspect to the whole efficiency debate which PAT kind of misses out, is that it does not contain the production volume. So, as soon as I told earlier, that efficiency would mean not only more money in the pocket of people, it will also mean more money for industries in their pockets. And as soon as you have more money for industries in their pockets, industries may produce more. So, what we are saying is that we are working towards energy efficiency, and this is what PAT scheme also misses out. So, what PAT scheme misses out is that are we reducing overall consumption, or are we only improving efficiency? We improved efficiency, we are now consuming for less kilowatt of energy per ton of production, but are we producing more? And as soon as we start producing more, we will be actually using same amount of energy, or we may actually end up start using more energy than we were using earlier, because now our cost of energy per unit of production reduces. So, it is not only required to work on efficiency alone, but what we need to look at as overall phenomena is that, is efficiency leading to a economic behavior where people will start consuming more because now they have dispensable income in their pocket. So, I have talked to you in terms of rebound effect. I have talked to you in terms of the behavioral at a political level, or the implication of some of the political compulsions through subsidies or through some other means where people have that perception of getting the subsidies. So, that kind of also adds to this kind of a behavior, giving dispensable income in pocket of people, in pocket of industries, in pocket of countries. For example, if countries also starts having more energy efficient devices, will they take this dispensable income which they kind of generated through efficiency mechanism, will they kind of take it and put in a pocket of people through some other means, and in turn increase consumption. So, overall governments needs to work in a phenomena, or the policymaker needs to work in a phenomena where they need to start looking at things more comprehensively. They cannot talk about efficiency alone. Whenever they talk about efficiency, they need to worry about overall consumption. Consumption and efficiency cannot be talked in isolation. And as I showed you through some numbers, that if you start looking at consumption and efficiency in isolation, there might be an issue where you will improve efficiency, but the net amount of the energy usage will not reduce, because your consumption or your production or your usage or your GDP will go up. This may go up, this may go up, this may go up, and this may go up. This in turn all will lead to, in terms of chi identity, the second term kind of going up. So, second term going up. So, even if the third term is going down, multiplying effect of these two things would be that you may actually end up at the same situation, or you may end up at a situation where you have more consumption also. So, like, that's a very interesting thing that you need to keep in mind while you are working in this as a scientist, or you are working as a policy maker, where policy cannot look at efficiency and consumption from two different eyes. It has to start working to work in cohesiveness, to kind of start looking at both the aspects from a same eyes perspective. There's one more aspect to it where we will talk about, we'll move from efficiency to sufficiency, and if there's one more topic which kind of I skipped, which I mentioned very briefly earlier, was a thing of degrowth. I'll touch upon that before I move into sectorial analysis after that. Thank you.